Welcome to session 4 of Unit 4. In this session, we are going to determine the ammonia contents in an ammonium salt. Let's look at the objective for this session. By the end of this session, you should be able to determine the ammonia contents in an ammonium salt using back titration procedure. Okay, so let's look at this example or this problem, and it will help us to understand back titration very well. This question is a bit technical. Ammonia in ammonium salts cannot be determined directly using neutralization methods. Indirect methods are therefore used, in which case an unknown amount of the salt is treated with an alkali and excess alkali treated with an acid. We have three solutions here. First is a solution of sodium hydroxide, in other words, pure sodium hydroxide, of which some was fetched to prepare H. So they fetched some of this sodium hydroxide, and then this quantity of the ammonium salt was now dissolved in it. Okay, and then H is a solution of 0.1 molar. We have three solutions here. In the previous session, the example that we looked at, the calcium oxide and in the rock sample, we had the initial concentration of the solution that was treated with the calcium oxide. But here, we don't have the concentration of this solution, the sodium hydroxide, that was treated with the ammonium salt. So first of all, we need to titrate between I and J so that we can find the concentration of the pure sodium hydroxide. And when we have it, that becomes our initial concentration. And it will appear as this. It will appear as 1 dm cubed of that concentration that we will find of this sodium hydroxide was fetched, and this amount of the salt was now dissolved in it. And we expect a reaction between this sodium hydroxide and this ammonium salt. So the ammonium salt is going to consume some of the sodium hydroxide, but there will be excess. So the excess would now react with this HCl. So that is the plan. Now let's look at the task is here, and these are questions for us to solve. We are to find the amount concentration of J. We are to find the concentration of H in mole per dm cube, the moles of sodium hydroxide consumed in the reaction, the mass of NH3 produced, the mass of NH3 that will be produced if 5 grams of the ammonium salt were treated with the excess alkali. And we are to take the average volume of I used in the first titration to be 22.70. The first titration, that is the titration between the acid and the pure sodium hydroxide. And the average volume of I used in the second titration to be 16.5. That's the titration between the acid and the, let me say, mixture, where we have sodium hydroxide treated with the sample. So let's see. We are starting with the HCl because that is where we can get enough information. We were given the concentration to be 0.1 molar or mole per dm cubed, and then we were given the average volume of it used to be 22.70. Let's interpret the concentration. If 1000 centimeters cubed contains 0.1, then this 27.0 of that 1000 will contain how many moles? That gives us 0.00227 moles. So we are now using this to find the corresponding moles of the sodium hydroxide. This 22.70 reacted with the 25 cubic centimeters of the sodium hydroxide. But from this balanced equation, 1 mole of sodium hydroxide reacts with 1 mole of the hydrochloric acid. So moles of NaOH is equal to moles of HCl. If that's the case, then the moles of sodium hydroxide is 0.00227 moles. So this is the number of moles contained in the 25 cubic centimeters of the sodium hydroxide. So let's move this one into 1000 centimeters cubed. And here we can say that if 25 cubic centimeters of sodium hydroxide contains 0.00227 moles, then 1000 cubic centimeters will contain this. Or we can say if 25 is equal to 0.00227, then 1000 is equal to x. You cross multiply, make x a subject. We are going to get this same answer to be that is 0.091. So this is the initial concentration of the sodium hydroxide. In other words, the sodium hydroxide that was fetched and now treated with the mass of that sample is 0.09. So some of this concentration will be consumed by the ammonium salt. Okay. But we needed to find this because the question was silent on the initial concentration of the sodium hydroxide. Next is to find the excess. After the sodium hydroxide was treated with the ammonium salt, what was left is what reacted with the acid. So we are going to do again to find the excess. When we find the excess, then we can go and subtract from the initial concentration to know what was consumed by the ammonium salt. So going there, we were given the average volume of the acid used to be 16.5 cubic centimeters. So the same concentration. So we interpret and we have this corresponding mole. So this is the moles of the acid contained in that 16.5 that was used or that reacted with the solution. Once again, we do our mole ratio from the balance equation, which is 1:1. Hence, the moles of the sodium hydroxide that reacted with the acid is 0.00165. So this is the moles in that 25 cubic centimeters of the sodium hydroxide, because it is this 25 here that reacted with 16.5 of this. So if 25 is equal to 0.00165, then 1000 is equal to x. We do this and we have 0.066 molar sodium hydroxide. So this is the excess of the sodium hydroxide. Remember, we have already found the concentration of the sodium hydroxide before it was treated with the ammonium salt. So after it had been treated with ammonium salt, this is what was left. In order to know the concentration of this that was consumed, we just have to find the difference. So in finding the difference, we have 0.025 moles per dm cubed. How did we do that? We subtracted the excess concentration of the sodium hydroxide from the initial. This is the concentration of the sodium hydroxide before it was treated with the salt, and after it was treated with the salt, this is what was left. So this gives us 0.025 molar. Now we have to convert this into moles. This is concentration. We have to convert into moles. So moles of sodium hydroxide consumed is equivalent to the concentration of the sodium hydroxide consumed times the volume that was used. That is 0.025 moles per dm cube times 1 dm cube, which was the volume used, and that gives us 0.025 moles. This is the moles of the sodium hydroxide that was consumed by the salt. And so we can now use this one. We can write a reaction equation between the sodium hydroxide and the salt. So we can use, in ionic equation, we can use the hydroxide and the ammonium ion. And from that balanced equation, we can find mole ratio. And if we find mole ratio, we can now find the corresponding moles of the ammonia from this sodium hydroxide that reacted with the salt. So let's proceed. Now, this is the equation. We had the ammonium salt reacting with the sodium hydroxide to give us the ammonia and water. And from the here you should note that the spectator, this is the ionic equation, so don't be confused. So this one is representing the ammonium salt, this is representing the hydroxide, the sodium hydroxide, and we'll have this product. And from that equation, 1 mole of the hydroxide reacted with 1 mole of the ammonium ion to give us 1 mole of the ammonia. In other words, 1 mole of the OH minus is equivalent to 1 mole of the ammonia. And so if the mole ratio is 1:1, then straight away the moles of the ammonia NH3 is equal to 0.025. That's the moles of the OH that was consumed. So if we know the moles, then we can find the molar mass, that is 17 grams per mole of the ammonia. And if you know the molar mass of the ammonia, we can find the mass from the relation N is equal to small m over capital M. Thus, amount N is equal to mass over molar mass. We make mass the subject, and we have number of moles times molar mass. And so we go for the moles of the ammonia and multiply by the molar mass of the ammonia, and that gives us 0.425 grams. The last question is to find the mass of ammonia that will be produced if 5 grams was used. In the problem, we were told that it was 3.75 of the ammonium salt that was used to react with the base, and that gave us this amount, this mass, 0.425 grams. That's the mass that we calculated. If that 3.75 that was used gave us this 4.25 grams, then if they had used 5 grams, what mass would have been produced? So if 3.75 is equal to 4.25, then 5 grams is equal to X. We would cross multiply, make X the subject, and we'll have this relation, which will give us 0.566 grams of the ammonia. So if they had used this 5 grams, they would have produced 0.566 grams of the ammonia. My good friends, we are ending the session here. I hope you enjoyed it.